Some materials can carry electric current better than others. These materials that are good conductors have what we call high conductivity. This is an intrinsic property to the material. It doesn't matter how much you have or the shape it's in, copper always has the same conductivity. However, for our class, we tend to think in terms of how materials resist current. So we have a nice relationship between conductivity and resistivity, which we call ρ. High conductivity, therefore, means low resistivity. Now, the intrinsic properties of the material aren't the only factors in how well the material can conduct current. The shape of the material matters too. Again, we care a lot more about resistance than we do about conductivity, so we've defined resistance to take into account both resistivity and the shape of the wire. Here, A refers to the cross-sectional area, and L refers to the length. You can think of this like water flowing in a pipe. If you increase the area of the pipe, there's a lot of room for the water to flow with a strong current. If you make it really thin, the water really struggles to make it along the pipe. And you can carry out the same kind of thinking to understand how length affects resistance. Now, these relationships are useful for figuring out how different wires and resistors will compare to each other. We may have different shapes and ask you to predict which has the highest resistance or current.